Alright, today we're starting the next topic area. So it's called cubics and quartics, or polynomials is probably a better way of talking about it. It's polynomials, but it's mainly power 3, power 4 that we're talking about here in this. So first of all, some definitions, and a lot of these you already know, but it's just not written in this form. So here's a polynomial. Polynomial is just something with power of x. All right. Number, if the number's a 0, it's called a zero polynomial. So when talking about the number 0, I literally mean 0. All right, so it's a zero polynomial. It's got no x's in there at all. All right, get rid of that. The leading term, so that's just the first term, whatever that might be. The degree, the biggest power. So if the biggest power is 5, it's degree 5. So monic. So if this coefficient here is 1, and the constant is the term on the end. So in this example that I've got here, this is a harmonic polynomial because it's 1 lot of x to the 4. It's a degree 4 because that's the highest power of x, and the constant term is -2 on the end. All right, so no doubt some people are going, oh, why are they using p here? We've used f before. All right, p for polynomial. All right, so again, we've done this stuff before. So for part A, so what does p of 1 mean? P of 1 means that you stick 1 into the equation, polynomial, where x is. So 1 to the power of 4 is 1, minus 3 times 1 minus 2. 1 minus 3 minus 2. And hopefully that is minus 4. All right. And then, of course, p of -1 would be -1 to the 4 minus 3 times -1 cubed minus 2. All right, even powers of negatives always come out as a positive, so that's +1. And odd powers of a negative always come out as a negative. All right, so if you've got to think about two negatives make a positive, so if you've got an even number, then they'll all pair up. If you've got an odd number, there's going to be one odd man out. All right, that's another way of looking at it. So 1. Here, -3 times -1 is +3 minus 2. 4 minus 2 should be 2, I believe. All right, so we've done that sort of stuff before. All right, and this sort of stuff, we've done this before too. You may not remember Q, why Q? Because it's different to P. No reason. So next year in year 12 in particular, but there might be a couple of polynomials in a question, so you've got to call them something different so that we don't get confused about which one's which. So we've got Q here. Doesn't matter what you call them F, call them H, call them Q, Z, whatever. Just P and Q and F and H seem to be, and G seem to be common. Anyway, I'm waffling. All right, so Q, here's some information. All right, and this information here sometimes people get confused by. So Q of -1 equals Q of -2, not -2, Q of 2 equals 0. So what that means is this. It means that Q of 1, -1, is 0, and Q of 2 is also 0. Okay, so if we find, now we stick in -1, so we've got 2 times -1 to the 6 minus -1 cubed plus a times -1 squared plus b times -1 plus 20, and that's 0. Right, I'm not going to be able to squeeze that in, so I'll just have to leave that there. So again, and it's an even power, so you've got 6 negative ones, so they pair up. So it's 1, so it's 2. Here we've got odd, so we've got 2 of them pair up, giving us a positive, and we've got an odd man out, and then we've got this negative here, so that's a plus 1. Plus a minus b plus 20 equals 0. Collect our like terms. A minus b plus 23 equals 0. So here we've got an equation. And then we'll get another equation from here, from our Q2. So our Q2, Q of 2, I should say. So put 2 in there, 2 times 2 to the 6 minus 2 to the 3 plus a times 2 squared plus b times 2 plus 20 equals 0. All right, 2 to the 6 is a bit. You get your calculator. I haven't got one handy. So 2 2s are 4, 2s are 8, 2s are 16, 2s are 32, 64, I believe. 64 times 2 is 128. 2 cubed is 8. 2 squared is 4 equals 0. So 140. So I'll go 4a plus 2b plus 140. 120 minus 8 is 120 plus the 20 there. And so now we have a second equation. All right, so the thing in the end that said finding values of a and b, so we need to now solve those simultaneously, which you can do by hand or you can do by calculator. And I'm going to do the calculator here just to remind you of what it is. All right, so keyboard, this one here, click on it, there we go. So we've got a, I'm going to use x's and y's, so I'm going to use, for a, I'm going to use x minus y, and this. All right, going to use those. You can use the a's and the b's, but you've got to go searching for it. So we don't want to have to do that if we don't want to. Don't have to. So x minus y plus 23 equals 0 is one equation. The other equation is 4x plus 2y plus 140 equals 0. And we want to know both x and y. So exe, so negative 10 and 13. So a is negative 10 and b is 13. So a equals negative 10 and b equals 13. All right. So there's that particular question. All right. So here's an example of where where we got two polynomials, P and Q, and we need to know that because we need to be able to tell the difference between the two. All right, so P plus Q for A here, P plus Q. A bit ugly. All right. P plus Q just simply means that we add these things together. All right, so it's only one lot x cubed. We've got x squared here, none here, so plus x squared because we're plussing. Minus 6x plus and a minus is still a minus, and minus another, so minus 9x. And then 3 plus 1 is 4. All right, simple as that. B, this time we're subtracting. Minus this time. All right, so we've got x cubed. Minus 6x, minus and minus is a plus, so minus 6 plus 3 is minus 3. Minus 3x. We've got x squared here, which I should put in order, go from the highest power to the lowest. And then 3 minus 1 is 2. All right, and then the last one is we've got to multiply, right? So going to multiply these things together. Like that. So we've got to expand and collect all our like terms, which is a bit of work. All right. So what I'm going to do is I'm again going to show you how we can do that on the calculator rather than doing it by hand. It's just time consuming by hand, and that's all. And something expanding like this, yeah, would they ask you? I mean, they could technically ask it. All right, so here's our calculator. Action, transformation. Let's go simplify. What are we simplifying? X cubed minus 6x plus 3 times by. You don't need to put the times. It assumes that that's what you want to do. The programmers have got that one right. So minus 3x plus 1. And then there we are. So I've used the wrong function, haven't I? Action advanced. Expand, not simplify. All right, let's just drag that down. There we go, that's better. All right, so it's x to the 5 minus 3x to the 4 minus x cubed plus 21x squared minus 15x plus 3. There for that. I'm not going to write that answer down on the other. I won't remember, so all of that. All right, so that answer would be there. All right, now the next bit on this is what we call equating coefficients. So the best way to say that is if two polynomials are equal, are equal, then their coefficients must be the same. So here we've got here polynomial px equals x cubed plus 3x squared plus 2x plus 1, and it can be written in the form x minus 2 x squared plus bx plus c plus r. All right, so in other words, x minus 2 was kind of a factor. There's a bit of a remainder, and we'll get into that later down the track when we're dividing polynomials. All right, so what do we have to do? So px, I'll bring that in later. So this one here, first of all, x minus 2, x squared plus bx plus c. It's a bit ugly, that squared there. This one. There we go. All right, so x going to multiply x times x squared is x cubed. X times bx is bx squared. X times c is cx. Then minus 2 times x squared minus 2x squared. Minus 2 times bx is minus 2bx. Minus 2 times c is minus 2c. And then, of course, we've got that plus r. All right, collect our like terms. So we've got x cubed plus b minus 2. So taking the x squared out as a common factor. Plus c minus 2b. Lots of x. And then minus 2c plus r. All right, now is where I'm coming with my p. Here's my p. And my p is x cubed plus 3x squared plus 2x plus 1. So from this, when we're saying equating coefficients, so if these two polynomials, that one there and that one there, are the same, which we're told up here it is, we can write this one in this form, so they've got to be the same. And what that means is the coefficients of the particular x terms, or the number bit on the end, the number bit being the bit without the x's, have got to be the same. Now we don't need to, in this case, worry about this x cubed, because they're both already the same. But what we do know here with these first, with the x squared coefficients, is that we know that b minus 2 is equal to 3, which means that b would be equal to 5. And what we know here is that c minus 2b is equal to 2. So c minus 10 is equal to 2. So c is 12. And what we know here is that the number part on the end, 2c plus r, is equal to 1. So minus 24 plus r is equal to 1. So r is equal to 25. All right, so this polynomial, this one here, can be written in this form here. So p of x, alternative one, is that it can be x minus 2, x squared, plus 5x, plus 12, plus 25. All right, so that's all there is for question 6a. So on your work plan is the questions you need to do. If you've got any questions about that, then send me an email and I'll record an explanation. And that's about it. So have fun.